today we are going to talk about section 11.6, proportions and volumes. So in the last lesson, you learned that if two figures are similar, then the areas of the two similar figures would be in the same ratio if you square them. So if we had, let's say, two triangles that are similar. So we say triangle ABC is similar to triangle DEF, and we will say they have the ratio of 2/5. What you learned then that the area of triangle ABC divided by the area of triangle DEF would equal 2/5 squared. So that would be 4/25. That the areas would be in the same ratio if you square each number. Okay, so how is this going to work with volumes? So let's look at two right circular cones. Let's see. I'm going to draw the circle first and then make the cone. Okay, so this first cone has a radius of 8. Uh-oh. So the radius is 8 and the height is 14. I am going to make another right circular cone, this one a little bit larger, with the radius of 12 and the height of 21. The first question is, are they similar? The answer is yes, they are similar because the radii and the heights are in the same ratio. So how do we check that? We will take the radius of the smaller cone and divide it by the radius of the larger cone. We're going to simplify that. We'll divide each of them by 4 to get 2/3. So this is the smaller cone. This is the ratio of the radius of the smaller one divided by the radius of the larger one. Okay, so we're going to keep it that way. So if we do the same thing with the heights, which is 14 for the smaller and 21 for the larger, divide both of those by 7, we get the same ratio. Again, make sure you do smaller over larger. So these are in the same ratio. So are they similar? Yes, because the radii and the heights are in the same ratio. Okay, so now that we know that they're similar, we can compare their volumes. So let's find the volume of the smaller cone, and then we need to find the volume of the larger cone. Okay, so the volume of the smaller cone, 1/3 pi r squared times the height is the volume equation. The radius of the smaller cone is 8. The height is 14. So 1/3 times pi times 64 times 14. Okay, so let's see what that number is going to be. So 64 times 14 divided by 3, 298 2/3. Times pi is the volume of the smaller cone. Let's look at the volume of the larger cone using 1/3 pi r squared times h. The radius of the larger cone is 12, and the height is 21. So this time the 3 will divide into the 21, and we can make that 7. So we just need to calculate 144 times 7. And we get 1,008. Times pi. So we know that the ratio between the radii and the heights are 2/3. So let's see what the ratio between the two volumes are. So I'm going to do volume of the smaller cone divided by the volume of the larger cone and see what happens. So I will take that value, 298 2/3 pi, and divide it by 1,008 pi. We know our pi's will cancel. So let me go back to the calculator and see what happens when I divide these two numbers. So 298 divided by 1,008 . If I put it into math frac, or I put it into fraction form, I get 8/27. So this ratio will simplify to 8/27. How does that relate to the ratio between the radii and the heights, which we had to be 2/3? So we have 2/3 ratio, let's see, let's put between the radii and the heights. How does that relate to a ratio between the volumes of 8/27? That's going to be your conjecture. So see if you can figure that out, or I want you to figure it out. And then I want you to complete the conjecture. With your educated guess. So the conjecture is, conjecture 97, if corresponding edge lengths, or in our case, radii and heights, of two similar solids compare in the ratio of m/n, then their volumes compare in the ratio of blank over blank. Fill it out. Bring your notes to class tomorrow, and I'll see you then.